100 miles off the coast of Antarctica in the Amundsen Sea, it's December, and the ice is starting to break up. Scientists from the United States and from Sweden have come here to sample the sea ice to try to unlock the secrets hidden inside the ice. Funded by the National Science Foundation, this team uses a hollow core drill to bore into and remove 14-centimeter diameter cylinders of the sea ice. As the drill breaks through the bottom of the sea ice, small teeth at the bottom of the drill grab the core and bring it up inside the drill. This ice looks solid, but it is actually quite porous. Tiny channels called brine channels carry concentrated seawater between the frozen ice. In that seawater live algae and bacteria, and they thrive on the nutrient-rich waters of the Amundsen Sea. These samples will be collected and taken on board the Oden for analysis in the onboard labs.
We've lost about 17 centimeters of snow here, and now we're about to core. The snow is about, or the ice is about 1.5 meters thick. The ice is rafted in areas, so meaning that it's kind of layered like this on top of each other. Usually high winds will force flows underneath each other, and that's what's forming here. It's not just a single layer of ice. And so we're going to start coring here. This is about 1 meter thick, and we're going to have to add an extension piece about halfway through. So here goes. An electric motor.
When the sea ice exceeds the 1 meter length of the core drill, the drill is brought up, emptied, and then an extension is added to the core to make it go through thicker ice. Sea ice consists of freshwater crystals with salty brine running in channels between them. Algae and bacteria live in these nutrient-rich brine channels. Students at Liverpool High School helped me to design an articulated pole that I could use to push an underwater video camera through the hole in the sea ice and to get a view of life below the ice itself. The algae and bacteria that live inside the ice appear as brown areas in these photos. This algae and bacteria are of particular interest to the scientists because they provide gases to the atmosphere and food for the life under the waves. Once the sea surface freezes into a layer, storms break the layers into ragged blocks that are jumbled into piles and refrozen again. The most abundant animal in all of Antarctica are Antarctic krill. Krill use the bent appendages in the front of their body as a basket to filter the tiny diatom algae from the water. Larval krill can live right in the nooks and crannies underneath the sea ice, and then schools of krill swim in great swarms. Under the ice at this station, we were surprised to find dark patches that look like colonies of bacteria growing right on the surface of the ice blocks. With no nearby streams and rivers bringing sediment and no pollution from humans, the water under the Antarctic ice is generally crystal clear. However, the most interesting water were in the polynyas. Polynyas are open bodies of water where the sea ice has been blown away from the coast. Here, nutrient-rich waters upwell from the great depths. Nutrients plus sunshine makes the algae bloom and makes the Amundsen Sea polynea one of the most naturally rich and productive seas in the world. I'm Jeff Peneston, PolarTREC teacher for 2008 aboard the Swedish icebreaker Oden.